What if I told you your brain has been hacked, not by code, but by chemistry? Right now, a molecule called dopamine is controlling your every move, what you crave, what you chase, what you can't stop checking, scrolling, needing. And it's not your willpower that's weak. It's your brain's reward system that's been hijacked. Your ancestors used dopamine to survive, to hunt, to bond, to protect. But today, you're being fed supercharged digital dopamine hits. Notifications, infinite scroll corn loops, reward algorithms all engineered to rewire your brain against you. You can't focus. You feel numb, anxious, impulsive, and deep down, you know something's wrong. But here's the terrifying truth. This isn't accidental. It's intentional. Your brain has become a battlefield, and dopamine is the weapon. This video isn't just information. It's your last warning before you lose your focus and your future for good. Let's begin.
The silent hijacking of your brain, a deep dive into the neurochemical siege. Your brain, the most complex organ in the world, is made up of approximately 86 billion neurons with 100 trillion synapses through which these neurons communicate with each other. This communication happens through neurochemicals called neurotransmitters, and among them, dopamine is one of the most important. Dopamine plays a central role in motivation, reward processing, learning, and decision-making. Evolutionary context and dopamine's adaptive role. From an evolutionary perspective, the function of dopamine has been quite adaptive, evolving over millions of years to promote survival and reproduction. Dopaminergic neurons signal reward prediction error (RPE), meaning the difference between expected and actual rewards, which helps in learning by reinforcing beneficial behaviors and discouraging harmful ones. For example, when an animal suddenly finds a food source, there's a burst of dopamine that rewards its hunting behavior. This kind of system encourages behaviors that enhance survival, like finding food, mating, forming social bonds, and avoiding danger. In the wild, natural rewards like food and social contact are limited, and the dopamine balance remains maintained, which is called dopamine homeostasis. Modern digital hijacking and supernormal stimuli. But in today's hyper-connected digital age, this natural dopamine system is being manipulated through supernormal stimuli, artificially exaggerated triggers that increase dopamine far beyond natural levels. Digital inputs like smartphones, social media platforms, online games, and pornography cause dopamine surges that are endless, unpredictable, and intense. As a result, your reward system gets hijacked, leading to compulsive behaviors and addiction, which directly affect your focus, cognition, mental health, and social relationships. What is dopamine? Neuroscience of motivation and reward prediction error, dopamine synthesis and pathways. Dopamine is made from the amino acid tyrosine, involving enzymatic steps, through the enzymes tyrosine hydroxylase and dopa decarboxylase. This dopamine is mainly produced into midbrain regions. Ventral tegmental area VTA, substantia nigra pars compacta SNC. These dopamine neurons project to several brain regions such as nucleus accumbens NAC, critical for reward, reinforcement, motivation. Prefrontal cortex PFC, responsible for executive functions like attention, decision-making, working memory, and impulse control. Amygdala, processes emotions, especially fear and reward value. Hippocampus, plays a key role in learning and memory consolidation. Beyond pleasure, the wanting versus liking framework. It's wrong to consider dopamine merely as the pleasure chemical. Kent Berridge and Terry Robinson proposed the incentive salience model, in which they explained to different aspects of dopamine. Wanting motivation, craving, driven by dopamine, which creates the desire or craving for rewards. Liking hedonic impact, the actual pleasure derived from the reward, mediated by opioid and endocannabinoid systems. Dopamine activity spikes in the anticipation of the reward-wanting phase and reduces slightly when consuming the reward-liking phase. This explains why craving can last longer while the actual pleasure may be short-lived. Reward prediction error (RPE). Pioneering studies by neuroscientist Wolfram Schultz showed that dopamine neurons encode RP signals. Positive RP, When the outcome is better than expected, dopamine neurons fire in bursts, reinforcing the behavior. Negative RPE. When the outcome is worse than expected, dopamine neurons stop firing. No RPE. When the outcome matches the expectation exactly, baseline firing occurs. This error signal helps adapt learning so that your behavior can maximize future rewards. How dopamine addiction develops: variable rewards, operant conditioning, and neuroplasticity. Operant conditioning and variable ratio reinforcement. Behavioral psychologist B.F. Skinner showed that a variable ratio reinforcement schedule, where rewards are unpredictable but frequent, creates the most powerful and persistent habits. This intermittent reward pattern leads to compulsive behaviors that are stronger than those created by fixed reinforcement. Digital platforms exploiting variable reinforcement. Social media likes, comments, shares, and follower counts are unpredictable, which fuels compulsive checking. Gaming. Random loot drops, surprise achievements, and leveling rewards engage dopamine circuits through unpredictable reinforcement. Pornography, novelty, and escalating stimuli increase cravings through dopamine surges, leading to demand for more extreme content as tolerance builds. Endless scrolling and binge watching, infinite feeds, and autoplay keep dopamine surges continuous, fragmenting attention and reinforcing compulsive use. Neuroplasticity and habitual shift. Repeated dopamine spikes lead to long-term potentiation (LTP) in corticostriatal pathways, strengthening habits in the dorsal striatum, the brain region responsible for automatic, habitual behaviors. Meanwhile, chronic dopamine overstimulation causes synaptic pruning and reduced gray matter density in the prefrontal cortex, weakening executive control, self-regulation, and impulse resistance. This shifts behavior from goal-directed to compulsive habitual. The neurobiology of dopamine addiction: structural and functional brain changes, structural changes. Structural MRI studies show reduced gray matter volume in the dorsolateral prefrontal cortex DLPFC and anterior cingulate cortex ACC in individuals with excessive digital media use. Diffusion tensor imaging DTI shows weakened integrity of white matter tracks between the PFC and subcortical regions, disrupting communication.
Post-mortem studies show reduced dendritic spine density in prefrontal neurons in addicted brains. Functional changes. Functional MRI studies show hyperactivation of the nucleus accumbens NAC when addiction cues, games, pornography are shown, indicating sensitization of reward circuits. During inhibition in sustained attention tasks, hypoactivation of the prefrontal cortex is consistently observed, indicating executive dysfunction. Resting state connectivity analysis shows impaired coordination between frontal and limbic regions, associated with impulsivity and compulsivity. Dopamine receptor downregulation. Chronic overstimulation downregulates dopamine D receptors and reduces the function of the dopamine transporter DAT. As a result, the efficacy of dopamine signaling decreases, leading to tolerance, meaning more intense or frequent stimuli are needed for the same effect. Alongside, anhedonia develops, difficulty in deriving pleasure from natural rewards. Mental health consequences: emotional dysregulation, anxiety, depression, and social impairment. Emotional dysregulation and mood disorders in the cycle of dopamine addiction. Intense surges are followed by crashes, increasing mood instability and irritability. Meta-analyses e.g. JAMA Psychiatry 2020 found strong associations between heavy social media use and depression, anxiety disorders. Dopamine dysregulation also affects other neurotransmitter systems like serotonin and norepinephrine, further exacerbating mood disturbances. Hypothalamic pituitary adrenal HPA axis dysfunction. Chronic dopamine addiction overactivates the HPA axis, increasing the stress hormone cortisol. High cortisol impairs hippocampal neurogenesis, leading to memory deficits and mood disorders. This stress sensitization further promotes compulsive behavior, as it becomes a maladaptive coping mechanism. Social isolation and loneliness despite virtual connections. Dopamine addiction undermines real social bonding. Research shows that heavy digital users report more loneliness, less empathy, and decline in social skills. In adolescence, Excessive screen time hinders the development of social cognition, affecting theory of mind and emotional intelligence. Relationship dysfunction. Pornography addiction disrupts the neurochemical balance of oxytocin and dopamine, which are critical for bonding and intimacy. Clinical Studies Archives of Sexual Behavior 2017 link compulsive porn use with reduced sexual satisfaction, relationship conflicts, and intimacy avoidance. This cycle breeds isolation and relational quality decline, which further fuels dopamine-seeking behaviors to fill emotional voids. Real-life stories. Dopamine addiction in action. Jake's story. Jake, a 26-year-old software engineer, lost his focus in social connection due to excessive gaming and social media.
Cognitive tests showed executive function deficits due to prefrontal hypoactivity. Through a structured program, including a 60-day digital detox, CBT, mindfulness meditation, and aerobic exercise, Jake experienced neuroplastic recovery. MRI follow-ups showed increased prefrontal gray matter volume, and Jake regained cognitive control and repaired relationships. Sarah's story. Sarah struggled with shame, anxiety, and intimacy problems due to compulsive pornography consumption. Her therapy involved dopamine fasting, CBT, neurofeedback, and social skills training. She underwent repetitive transcranial magnetic stimulation (RTMS) sessions targeting the DLPFC, accelerating neuroplastic changes. Within a few months, Sarah regained emotional regulation and cognitive control and rebuilt meaningful relationships. Science-backed strategies to break free from dopamine addiction and reclaim your life. 1. Digital detox and dopamine fasting. Intentional abstinence from digital dopamine triggers helps recover dopamine receptor densities and signaling pathways. Controlled trials showed significant improvements in impulse control and executive function after fasting. Start with 1 hour of fasting, then gradually increase to 24 to 72 hours. 2. Mindfulness meditation. Mindfulness enhances PEFC function and increases connectivity with the striatum. It reduces amygdala hyperactivity, lowers stress, and improves working memory. Neuroimaging studies show that long-term practice increases cortical thickness. Daily practice of 10 to 20 minutes is recommended. 3. Structured deep work sessions. Cal Newport's deep work method promotes distraction-free focus blocks, strengthening attentional networks. The Pomodoro Technique 25-minute focus plus 5-minute break helps build cognitive endurance and reduce procrastination. Through repeated practice, behavioral conditioning reshapes neural circuitry to support sustained attention. 4. Physical exercise. Aerobic and resistance training increase dopamine receptor density and brain-derived neurotrophic factor BDNF, supporting synaptic plasticity. They improve mood, executive function, neurogenesis, and stress resilience. Who recommends 150 minutes of moderate-intensity aerobic exercise weekly? 5. Purposeful dopamine replacement. Intrinsically rewarding activities are volunteering, learning naturally stimulate dopamine. These activities provide long-lasting satisfaction and restore motivation toward meaningful life goals. Rebuilding social support and forming positive habits replace compulsive digital behaviors.
Final thought. Harnessing neuroplasticity, your brain's superpower for recovery. Dopamine addiction causes neurological and psychological damage, but the brain's remarkable plasticity offers a path to recovery. Through awareness, science-based interventions, and consistent practice, you can repair circuits, restore cognitive control, and move beyond compulsive digital dependencies to live a fulfilling and focused life. Your brain, even if hijacked, has the power to rewire itself, allowing you to regain your focus, mental health, and real human connection. You're not broken, your brain's just been hijacked. But guess what? You can take it back. Say no to cheap dopamine. Say yes to real focus, real peace, and real life. Subscribe if you're done surviving and ready to start living. See you in the next one.